Okay, let's talk about the third part of this section. Section is very interesting. We know that the future value is equal to the principal times 1 plus r over n to the power nt. Here p is the principal, r is the interest rate, n is the compound payment period time, like n compound payment period. T means years, okay? And A is the future value. And the principal is also called the present value. Okay, so you deposit $1,000. After several years, you want some back, the return. That's A. So sometimes we have this idea. We want some amount dollars as feedback. And then we want to calculate how much money we need to deposit, invest. We need to invest, okay? So that's another like the job. So assume you, for example, we have this amount of money, A dollars. We want to get for example, $1,000 back. And assume we have some expectation. The interest, this is expectation. And expectation is supported by some interest rate. Interest rate, that's something in your mind. It's interest rate. And also you know how many years you want to invest. And you expect a certain number of a payment period each year. And then you don't know the principal you need to deposit. The principal is also called present value. Like the current, you need $500 to deposit, or you need to $600 to deposit. Okay, so this is the principal value you need to present. You need to deposit or invest. Okay, but the present value together with this coefficient is equal to the future value, and then we move this, or we divide this equation by this coefficient. We get the present value is A times A times 1 plus R over N to the power negative NT. Negative NT means when you divide it to divide the equation by this coefficient, it becomes negative, reciprocal. Okay. And this is a case when you have the N compound payment period. If you have a continuous compound continuously, then it is A times e to negative RT, because if you have a continuous compounding, it looks like this between the present value and the future value. Okay, so these two are the formulas for the present values if you already have some future value in your mind. Okay, so that's a theorem. Let's make the theorem clear, but basically it's the same thing. So the present value formula. Present value formula says the present value P of A dollars to be received after T years. Assuming per annum, not annus, annum interest rate R compounded n times per year is P is equal to A times 1 plus R over N to power NT, negative NT, power negative NT. So you just go back, you move this coefficient to the future value. It's present stuff, present value. If the interest is compounded continuously, the present value is A times e to negative RT. The present is A times e to negative RT. Okay. So how do we use this type of idea in the life or in the finance? It's the following. For example, a zero coupon no interest bearing, non-interest bearing, zero coupon bond can be redeemed in 10 years for $1,000. How much should you be willing to pay for it? If you want a return of 8% compound monthly, B 7% compounded continuously. Okay, there's two interest rate. If we have 8% compounded monthly, so the present value, so it's this $1,000 is a value after 10 years, so it's a future value. You expect $1,000 as a return. So it's $1,000 times 1 plus interest rate 8%, monthly 12, and 10 years. Remember, it's 12 times 10. It's n times t. N is the number of payment period. T is the number of the years here. Okay, so this is actually 120. Negative. Sorry. Negative. To compute the present value, it is to the power negative nt. To compute the future value, it is to the power nt. It's negative. My bad. Pay attention, it's negative here. So it's $1,000 times 1 plus 0.08 over 12 to negative 120. And you use calculator to compute. It's more or less like 450.52 cents. So if you want this type of interest rate, and after 10 years you earn $1,000 back, you only need to pay $450. Okay, if you pay less, you earn more. If you pay more than it, you lose money. You don't have this interest rate. Okay, if you consider the other one, the 7% compounded continuously, so P is 1,000. It's always a future value. E to negative R 0.07. T is 10 years. Here the T is just the number of years. So it's 1,000 times e to negative 0.7. Again, you need a calculator to compute. It's about 496.59. It's more or less about 497. So you see here, it seems this one you need to pay more, this one you need to pay less. And in other words, it means this one you earn more, this one you earn less, right? So that's a way to apply this present value formula, present value formula. So you have some interest rate in your mind, and you have your expectation in your mind. You just want to see how much money you need now. Okay. Part 4 is determine the rate of interest or time required to double a lump sum of money. Okay, then this one we just studied the example. Okay, so we have two examples. Example 1. What annual rate of interest compounded annually should you seek if you want to double your investment in 5 years. Okay, you want to double your investment in 5 years. You're looking for the interest rate. Okay, so let's check. It is compounded annually, so n is equal to 1. If it is compounded annually, n is 1. Semi-annually, n is 2. Quarterly, n is 4. Monthly, n is 12. Daily, n is 365. Remember that? Okay, so n is 1. Okay, 5 years. So t is 5. So for example, let's write down the formula. The other one. P1 plus r over n, and t is equal to a. This is the formula. And so in this setting, a is 2p doubled, n is 1, t is 5. Okay, so we read the problem, we can determine this. And then let's plug in. So we get a P1 plus R T is 2P. Okay, so you cancel P and P, you get, oh, sorry, T is a 5, 5, 5, 5, 5, 5. T is a 5. 1 plus R to 5 is equal to 2. Okay, 1 plus R to 5 is equal to 2. And we're looking for R. We take fifth root, right? This is a base, we take fifth root. We're talking about positive number, and also this is an odd power. Okay, and then R is equal to fifth root of 2 minus 1. This is R. In the exam, let me make this clear. In the exam, if you see some problem like this, this is your answer. Because in the exam, again, you cannot have calculator. So in the exam, the answer in the exam. In the real life, of course, this number does not make sense. So we have to use a calculator to really compute the fifth root of 2 and subtract 1 from this number. In the real life, this number is more or less approximated as a 1.14 A698, and then minus 1. It's a 0.14 A698. So what you can say, it's approximately, this is real life number. Life, not lived. Real life number. So the interest rate should be 14.87%. Okay, so this is a interest rate, very big, very high. Okay, so once you know the number of years, you expect the compounded annually, and you expect double the investment, you need the interest rate like this. Second example. How long will it take for an investment to double in value if it earns 5% compounded continuously? Okay, so we need the time t. Compounded continuously, so P is, I'm sorry, not P is, P times e to RT is A. You see compounded continuously, it's a P times e to RT is equal to A. So here, the investment doubles the value, so A is 2P. And we're looking for T. R is a 0.05. So first you cancel PP from two sides. You get e to 0.05 times t is equal to 2. Okay? e to 0.05t is equal to 2. We're looking for the years, how long. This moment, we need the natural logarithmic function. We look for the exponent. Exponent is calculated by the logarithmic function. Here is the base e, so it's a natural logarithmic function. And then we divide it by 0.05, so t is over 0.05 is a multiplication with 20. Okay, again, let me make this clear. This is going to be the answer in the exam. But for us, for the real life, you need what? You need you can use calculator to compute it. Okay, so if you use calculator, it's approximately 13.86 years. If you have such interest rate, you compound continuously. The interest is compounded continuously. Then you need about 14 years to double your investment. Okay. And triple, if triple at value, triple at this rate. If we want to triple the value at this rate, you just change this 2 to be 3. Okay, so everything will be kept except this 2 is going to be number 3. So here 2 is the 3. So basically, you're solving the equation like this. You just change this 2 to be 3, 2 to be 3, 2 to be 3. So t is, to go through the same process, t is equal to 20 natural log of 3. Only change this here, like this. Double is 2, triple is 3. And again, this is another in the exam. And if you do the approximation, it's about 22 years. This interest rate is not big enough. Okay, so the last two computations depend on the application of the same formula, either compounded n times or compounded continuously. This is compounded continuously. If it is with p, it's you multiply with the RT or the NT. If it is with A, it's a negative NT, negative RT. Okay, so that's the second part of not the second part, the third and the fourth part of section 6.7. 6.7, the basic formula is this formula. You should learn the compounded interest rate, okay? And together with this, P, E, R, T is equal to A. So those two formulas. We just try to solve some number from this formula. You know the future value, you're looking for the present value. You know the present value, you're looking for the future value. Or you have the setting, you want to find the good interest rate. Or you want to know the time, after how many years you can double or triple your investment. Okay, either way, you have one number, 2, 3, 4 quantities. Or here is a similar thing, 1, 2, 3, 4. Here you have 5 because it's not continuous. And for this n, remember that compounded annually, n is 1. Compounded semi-annually, n is 2. Compounded quarterly, n is 4. Compounded monthly, n is 12. Compounded daily, n is 365. Okay, so that's the setting. Okay, we finish this video and finish this section. We will start the next section. Thank you.